Alright, your homework should have already been turned in and you guys should have graded that quickly. We have a lot to do today. And then your red book underneath your desk should be open to page 198 and you're solving a number 49. So I'll give you a couple more minutes to work on that. When everyone's ready, then Miss Osborne will push play. Okay, number 49 on page 198 in your red book. We'll use the red books often just for warm-up questions here and there and some review questions. But it says a red kite is 100 feet off the ground and is rising at 8 feet per second. A blue kite is 180 feet off the ground and is rising 5 feet per second. How long will it take for the red kite to be higher than the blue kite? Okay, so let's just write down what information we have. So first of all, let's write down the red kite. It says the red kite is 100 feet off the ground and is rising 8 feet per second. So it's already at 100 feet and it's rising, which means it's plus 8 per second. So x would represent seconds here. The blue kite is already 180 feet off the ground and it's rising, so plus 5 feet per second. So what they want us to find, this is the question that we're solving, how long will it take for the red kite to be higher than the blue kite? So we want the red to be greater than the blue, not equal to, because it doesn't say equal to, greater or equal to, it's just when is the red kite higher than the blue kite. And it says round your answer to the nearest second. So now that I have my equations, I'm going to set it up exactly like how the question's asking me. They want to know when red is higher than blue. So the red side was 100 feet already and it's rising at 8 feet per second. And we wanted that to be higher than the blue kite at 180 feet already plus 5 feet per second. So now if I go ahead and solve this, just like what we did yesterday, okay? No distributive property. Let's move our variables to one side. I'm going to go ahead and move the 5x, so minus 5x on the right side, minus 5x on the left side, which leaves me with 100 plus 3x is greater than 180. Then the next step here is I'm going to subtract 100 on both sides. And that leaves me with 3x is greater than 80. And the last step here is I'm going to divide by the coefficient of 3. Divide this side by 3, and that leaves me with x is greater than 80 divided by 3, or in this case, 26.66. So what this is saying, again, x represented my seconds. So the seconds are greater than 26.6 repeating. So the question said round your answer to the nearest second. Well, if I had to round that, that means the nearest second would be at 27. So my answer here is the red kite will finally be higher than the blue kite when the seconds is greater than 27. So it could be 27.1, 27.3, something like that. So that's more of like a word problem associated with these inequalities. Okay, today we're going to talk about compound inequalities. So this is 1-7 in your homework hotspot book. Today is September 13th, 2016. And this is my page 28 notes. Yours might be a little different, so make sure you check yours. And in my table of contents, we actually did not have a practice multi-step, so I'm going to cross that out, or you can squiggle it out, whatever you prefer. Because we didn't need an extra day of that. And this is page 28, which is 1-7, solving compound inequalities. Now, we know how to solve inequalities, but now we have this word called compound inequalities. Compound just means more than one. So we're going to start off with just an example, and then we'll go from there with continuing to take notes. So I want you to write this down. Put all real numbers that are greater than 0 and less than 10. So, compound means more than one. So if I look at these two inequalities that is written into one, it says all real numbers that are greater than 0 and less than 10. This word "and" here separates two inequalities. And the two inequalities, if you notice, the first one is all real numbers that are greater than 0. That's the first one. So let's pick a variable. Let's say x is the variable. If I wrote an inequality for x is greater than 0, we know what that looks like. And then the second one is less than 10. So in that case, I have x is less than 10. And we have these two inequalities into one because they use the word "and." So I want to think of some possible solutions that would work for these two inequalities. Okay, they have to be greater than 0 but less than 10. So what are some possible solutions here? Could it be 5? Is 5 greater than 0 and less than 10? Yes. It could be 1. It could be 2. It could be pi, 3.14. It could be 5.76295. It could be 9.99 repeating. Okay? Everything that is a possible solution has to be greater than 0 but less than 10. This would be considered a compound inequality because I have two inequalities, but all these solutions fit within those two. Now what would this look like when we actually graph it? So again, I have my graph. Now I know that it has to be greater than 0 and less than 10. So I'm going to go ahead and put 0 here. We'll go up by 5, 0, 5, 10, 15. As long as I have the two that I need. Doesn't matter what I go up by. Now we're going to graph one at a time. So if x is greater than 0, is that an open or closed circle on the 0? This is an open circle. And if x is greater than 0, I'm going to go ahead and shade just a little bit right now this way, showing that everything on this side is greater than 0. Now let's do the next one. X has to be less than 10. So again, open or closed circle. This is an open circle. And if x is less than 10, which way am I going to be shading? It's going to be shaded this way. So now that I have both of them, I'm going to shade what's in between, because since it has to fit both of these inequalities, it has to fit between both of these. So it doesn't extend past this and it doesn't extend past the 0. It's everything in between. Everything in the shaded region are possible solutions, and that's exactly what we wrote down up here. Okay, so this is considered a compound inequality. Now, the way that we would actually write this, instead of writing two separate ones with the word "and," now that is a way you could write it. What's one way of writing this, but instead of writing x 2 times, let's just write it 1 time. So the way that you would actually write this is x is in the middle. What's the smaller number out of the two, 10 or 0? 0 is the smallest, 10 is the largest. Okay? Now, to make this work, x has to be greater than 0. So, if I'm just looking at these two, x has to be greater than 0. X is greater than 0. I'm reading it backwards a little bit. And x has to be less than 10. So x has to be less than 10. Now, this represents that any solution, that could be x, is greater than 0, but it has to be less than 10. Okay, so that's how I would write this compound inequality. So one of the things that we did when we actually wrote this and graphed it is that the overlapping section on the graph represents solutions to both inequalities. So this example, I gave you the actual word problem and we wrote the two inequalities. We're going to be looking at just giving you the inequalities, or giving you something like this, the compound inequality, and we're going to graph it just from here. So to start out with, we are solving these compound inequalities with the word, and write this really big or in bold if you have a permanent marker, with and. So this is when we see the word and, because there's a difference between this word and another word. So solving inequalities with the word and, I'm going to highlight that, bold it, whatever you need to do to remember. So, let's try one together. Write this down. 4 is less than or equal to x plus 2, which is less than or equal to 8. So this is a compound inequality with the word and in it, because it looks similar to the one we just did. Now here's a helpful hint. We want to be able to graph this, which again, if we graph it, it needs to be an inequality that's simplified all the way. So put a big star by this, or maybe 2 stars, because this is important. What we want to do is we want to separate into 2 inequalities. So, I'm looking at these inequalities. How can I separate them into 2? What I want you to do is take your finger, cover up the second inequality and everything after that. Okay, this is the first inequality. I'm going to keep it covered. I'm going to write 4 is less than or equal to x plus 2. That's the first inequality. The second inequality is, I'm going to cover up the other inequality and everything to the left of that, and that would be x plus 2 is less than or equal to 8. Okay? So I wrote my 2 inequalities. Now I'm going to solve them. So if we look at the one on the left, I have 4 is less than or equal to x plus 2. I'm going to subtract 2 on both sides, which leaves me with 2 is less than or equal to x. But again, my variable has to be on the left side. So x is greater than or equal to 2. Again, since it's opening up, oops, I didn't write that right, did I? Should be this. Greater than or equal to. Okay, again, since it's opening up towards the x, when I flip it, it needs to make sure it's opening up towards the x. So I have x is greater than or equal to 2 on the left side. Over here, I'm going to subtract 2 on both sides, and I'm left over with x is less than or equal to 6. So whenever it's written like this, just remember these are 2 separate inequalities, and we can just rewrite them. That's one, and that's the other. So now let's graph it. So, make a big number line. And I know I have to have 2 and 6 on there, so I'm just going to put 2 on the far left, 6 over here. put 7, 1, and everything in between. So 2, 3, 4, 5, 6, and 7. Now let's graph what we know. So one at a time. X is greater than or equal to 2. So is this an open or closed circle on the 2? You should have said closed circle because of that equal to bar. And if x is greater than 2, which numbers would that make sense? 1 or 3, 4, 5, 6? If x is greater than, I'm shading this way. And I'm just going to shade a little bit right now. This other one, x is less than or equal to 6. So on the 6, open or closed circle. Closed circle because 6 is included in that. And if x is less than or equal to 6, I'm shading it to the left. So if you notice, again, everything that's in the middle should be shaded. All my answers have to be greater than 2 or 2 and less than or equal to 6. So my possible answers all fit in this area. It could be 2 or anything here or 6. So if you notice the last two that we've done, these are and compound inequalities. They're shaded in the middle. They collide in the middle. Same thing here. They collide in the middle. So we're going to do one more example and see if you can do it by yourself. So I want you to follow the steps we just took on that last one. Let's do negative 5 is less than or equal to 2x plus 3, which is less than 9. Go ahead and work with your neighbor closest to you. I want you to solve it and I want you to graph it. Okay, so my two inequalities here that I'm going to rewrite, in this case it'd be negative 5 is less than or equal to 2x plus 3, because again I just covered up that left or the right side. And then my other one is I'm covering up the left side, so I'm left over with 2x plus 3 is less than 9. So I'm solving it now. So on the left side, I'm going to take away 3 on both sides. And I'm left over with negative 8 is less than or equal to 2x. Then I'm going to divide by the coefficient of 2 on both sides, which gives me negative 4 is less than or equal to x. But I'm going to go ahead and rewrite that to give me x, it's opening up towards x, is greater than or equal to negative 4. So that was the first one you should have gotten. Let's look at the second inequality in this compound inequality. Again, I'm getting rid of the number not attached to the variable. So minus 3 on both sides. I have 2x is less than 6. I'm going to divide by 2 on both sides. And that gives me x is less than 3. So I have my two inequalities. And again, this is going to be an and, because when it's written like this, we know it's an and problem, because I'm going to show you the difference between the other ones. So now let's graph what we know. So I know negative 4, and it needs to go up to positive 3. So negative 4, I'll go up by 2's here. Negative 4, negative 2, 0, 2, 4, and so forth. So if I have this, I have x is greater than or equal to negative 4. Is that an open or closed circle on negative 4? Closed circle. And if x is greater than or equal to negative 4, that means every number to the right of that is greater than negative 4. Now x is less than 3. I'm going to go ahead and put a 3 in the middle of 2 and 4. Open or closed circle. Okay, this would be an open circle because 3 is not included because it's not equal to. And if x is less than 3, I'm shading to the left. Now notice again, they collide. So my answers to all my solutions have to be between -4 and 2.99999 because 3 is not included. Now if I wrote my answer as an inequality, compound inequality, again, -4 would be on the far left, 3 would be on the far right, x is in the middle, and I really just copy this down. Okay, x has to be greater than or equal to -4. So again, I have to flip it because if x is greater than or equal to -4, it has to be opening up to the x, and x is less than 3. So I would rewrite the inequality in simplified form to that. Okay, so that's our first type of compound inequality. The second type of compound inequality, so compound inequality is with the word or. So we have and or. Again, make that bold, highlight a box around it, whatever you need to do to see both. So let's look at a verbal description first. It says all real numbers that are less than 0 or greater than or equal to 10. So again, I have a lot of greater than, less than, equal to in this one sentence or statement. So we know that's a compound inequality because there's more than one inequality in here. So what I noticed first, let's pick out one of them that we know. All real numbers that are less than 0. So if I write an inequality that represents this, I have x has to be less than 0. Okay, then it has or greater than or equal to 10. So the second part is greater than or equal to 10. So x, again, because that represents all real numbers, is greater than or equal to 10. Now the word that divides them here is not and, it's actually or. So that's where we have our two compound inequalities with the words either and or. So let's talk about possible solutions. So let's talk about possible solutions for this first one. X is less than 0. What are some possible solutions? What's a number less than 0? It could be -1, -10, -114. It could be -7. Anything's less than 0. What about possible solutions for this inequality? X is greater than or equal to 10. It could be 10 because it's equal to. It could be 20. It could be 200. It could be 1,000. Anything there. Now if I look at these two inequalities, do they share any of the same solutions? No, they don't. So before we graph this, think about what this should look like when we graph this. If there's no solutions that they share, which ways am I going to be shading? You should visualize that there's no overlap at all. If they don't share any solutions, there's not going to be any overlapping. They won't touch the solutions. So what we're going to have is two separate solution regions. So now let's graph it. So again, I'm going to have the 0 and the 10. So 0, I'll do 5 and 10. Okay, on the 0, x is less than 0. Open or close circle. Open circle. If x is less than 0, am I shading to the right or to the left? Shading to the left. All these numbers are smaller than 0. Second inequality. X is greater than or equal to 10. Open or close circle. Should be closed. And if it's greater than or equal to 10, everything to the right is shaded. All these numbers would be greater than 10. So if you notice, with an OR compound inequality, we're shading opposite directions. When it was an AND, they were shading inside and overlapping. Now usually when you see an OR, you can't really rewrite that because they're separate inequalities. So your answer here would just be x is less than 0 or x is greater than or equal to 10. That would be my answer. I can't put those together because there's no solution that they both share. Let's do one more. Compound inequality with OR. And then you have a little keynote or take note to copy in your journal. And then I'll tell you what we're doing from there on. So usually when if they don't give you the word problem, they're going to give it to you like this. They're going to actually have it already separated for you, where it's 3x plus 2 is less than negative 7, or negative 4x plus 5 is less than 1. So right away when I see this word OR, they're going to ask me to graph this, solve it and graph it. I know that my graph is going to look like this, where they're shading in two opposite directions. So let's go ahead and simplify these inequalities one at a time. If I look on the left one, what's my first step? To get x by itself, I'm going to subtract 2 on both sides, which gives me 3x is less than negative 9. And to isolate the variable, I'm going to divide by the coefficient of 3, which gives me x is less than negative 3. So I simplified that first inequality. Second inequality, I'm going to get x by itself. So again, I'm going to subtract 5 on both sides, which leaves me with negative 4x is less than negative 4. Divide by the coefficient of negative 4. And that leaves me with x is less than, negative 4 divided by negative 4 is a positive 1. So x is less than 1. Now let's graph. So I need to have negative 3 and positive 1. So I'm just going to put negative 3 here. We'll put negative 1. Positive 1. If you want to fill in what's in between, that's fine. That's up to you. Okay, so now if I graph these, first one, x is less than negative 3. Open or close circle. Okay, this is an open circle on the negative 3. If x is less than negative 3, that means it's everything that's smaller than negative 3, which would be to the left. Negative 5 is less than negative 3. Okay, x is less than 1. Open or close circle on the 1. Open circle. If x is less than 1, uh-oh, I made a mistake. Now I knew I made a mistake because again this is an OR, which means it should be going both ways where they don't overlap. What did I forget to do here? What did I divide by? That negative 4. Hopefully you caught it way before I did. If you did, perfect. Sorry if you caught that a while ago. I make mistakes too. But that's awesome if you caught it. So, since I divided by that negative number, this has to be flipped, so it should be greater than 1. So in that case, it's still an open circle on the 1. If x is greater than 1, I know it's shaded to the right. And there you go. Okay, so the biggest things that you need to remember, and I guess I do too, is that if we have the word and, we know that we're going to be shading to the inside and they're going to overlap. If there's a word or, we know that they're going opposite directions, or they will not overlap at all. So what I have for you after you write that down is just a key concept. It pretty much explains everything we just did. You're going to go ahead and glue that into your journal. So as you're gluing that in, make sure you're reading that. I'm going to highlight some important words that you can as well. Okay, so for instance, here's a compound inequality with the word and they overlap. So our answer is going to have an overlapped shaded region. If it's an or, okay, each graph of the inequalities is separated. So that's why we end up having two separate shaded areas when it comes to the word or. So after you have that glued in, you can keep your journal out on your desk because you're going to need that. What Miss Osborne is going to hand out to you is the 1.7 exit ticket, which means this needs to be finished by the end of class. It's just 4 questions. So make sure you put your name at the top, your period, and answer the following questions. Pretty self-explanatory. You don't need to do anything for number 2, just tell me if it's compound or not. So put yes or no if it's a compound inequality or not. And then comparing the graphs between and or, we wrote that about 3 times in our notes. And then here's a multiple choice that's similar to one on the EOC. Once you're done with this, you'll turn that into the tray. And then what your homework is your Unit 1 review. Okay, we're going to finish this in class tomorrow and go over the answers because your tests will not be tomorrow, it will be the next day. But there's 20 questions on this unit review. So your homework, make sure you grab this before you leave, is going to be numbers 1 through, let's go through 11. Okay, your homework is to finish questions 1 through 11. Tomorrow you'll have time in class to work on 12 through 20. About 10-15 minutes, and then we'll go over all the answers so you have that to study for your test, not tomorrow but the next day. Okay, make sure you show me your work. There's lots of room on here unless you want a separate piece of paper, but homework is 1 through 11 on the Unit 1 review. Do not leave class without picking this up. So Miss Osborne will put this right by the turn-in tray, so after you're done turning in your exit ticket, okay, you're going to grab this, start working on it until that bell rings, and the 1 through 11 is the rest of your homework. Alright, we'll go over that in class tomorrow. Have a great day.